Hi, my name's Will Krozik, Scientific Services Manager at Chemical Computing Group. Today I'd like to introduce the Antibody Homology Modeling tool in MOE. In this session we're going to be creating a model directly from sequence, which is a useful workflow when we don't have access to the experimental structures, but we would like to leverage homologous templates. So let's get started. So I'm going to start by opening a sequence for us to model. I'll just get that from the sample mol directory. So here I'm selecting a FASTA file. You can see it's just a sequence. It's small in terms of its file size. I'll select it in the open panel, hit OK, and MOE recognizes that that's a sequence and therefore opens it directly in the sequence editor, the second major window type in MOE. We use this to display sequences, and it's also our launching point to the various protein modeling tools that we have in MOE. Next, I'd like to just adjust how we view this sequence. So I notice we have to scroll along to view the entire sequence. So I'm just going to wrap the sequence, and I'll also switch from the 3-letter amino acid code to the single letter code. I can also adjust the font here using the scroll wheel. I see our sequence editor contains both the light and the heavy chain. Next, I'd like to annotate the antibody, so I can do that from the sequence editor, and I can select between our default themes such as IMGT and Kabat. Today though I'm going to use North, which splits our sequence into different panels. By default, our light chain is always displayed in the leftmost panel, subunit 1, and then the heavy chain displayed in subunit 2. Notice that the sequence has been colored to show us the CDRs, so I can identify here L1, L2, and L3 in the light chain, and conversely H1, H2 in the heavy chain. And notice the third CDR of the heavy chain is colored red, and that shows us that it's more variable than the other CDRs. Now that we have our sequence display as we'd like, we can move on to create our model. So for that I'll need the Antibody Modeler, which has been designed so that you can open it with the sequence loaded in MOE and then simply click Build to initiate that build process. The application itself comprises 3 main tabs. We've got the Model tab, which allows us to specify the sequences that we'd like to build, together with options for the type of model that we'd like to create and how it should be annotated. The second tab lists the potential frameworks, and the third tab lists the potential CDR loop candidates. The Antibody Modeler application can be used to build FEs, Fabs, single heavy chain models, full IGs, regular bispecifics, and SCFEs. In this case, we're modeling the chains in MOE in sequence mode, which is going to create an FE model having the exact same sequence as the input. I notice that the final result has been written to the database viewer, but before we inspect that, I'd just like to explain how we arrived at this point. So the first stage of the antibody modeling process is to search the PDB to find structures that contain a variable domain, and these are written to our framework tab together with a PDB code and a score. The scores are based on sequence identity. The hit list is sorted by the average score for both VL and VH frameworks. Beyond this automated workflow, I can manually select templates, and I can select different templates for each chain. In this case, one SY6 has been selected on the basis of it being over 92% identical to the query framework. Once we've identified our framework template, the next step is to search for CDR loop templates. MOE searches the PDB for CDRs that have the same length, the highest sequence similarity, whilst avoiding clashes. The selected template has a plus sign next to it, and this process is repeated for each of the CDRs in first the light chain and then the heavy chain. The 6 selected CDRs get grafted onto our framework, and I do have options here to customize which templates are queried so that I can leverage my own structures and have complete control over the selection of each CDR. The final result is written to the database viewer, which itself is the third major window type in MOE. It looks and feels like an Excel spreadsheet, but if I drag the model field open, you see that it actually contains the 3D structure of our model. This would also be our launching point to be able to calculate protein properties should we wish. In this case, the database viewer contains our final model, together with the query sequence and the templates that have been used. So I'm just going to send this model to MOE by double-clicking on the model field. I'm going to opt to clear the system, and in the main MOE window we see our structure appear, and you'll notice that the rendering scheme has been automatically extended to the model. We see on the left a slightly lighter coloured chain, which is our light chain, a slightly darker coloured chain representing the heavy chain. Notice that the CDR annotation has been extended to this model, so we can pick out in purple the L1, L2 and L3, and then conversely in the heavy chain H1, H2 and the red H3. Now that we have our 3D model, we can think about generating some surfaces, and we could even map various properties onto this surface. We can calculate electrostatics, or we could even think about identifying potential liabilities using protein properties. That brings us to the end of today's session, where today we've generated an antibody model directly from sequence. I hope that you've learned a lot today. If you have any questions, please do reach out to me at support@chemcomp.com.